Hello people, this is a very short seminar or rather very much condensed viewpoint of how we should see geology as a science as well as what fundamentals or what are the main factors that practically drives this science through ages. Now, considerably, I was working late night yesterday and I was making some points out of curiosity that why or how earth science had evolved through time. Now, the big problem with earth science is that whenever we try to analyze this subject, we more or less try to engulf and notch some informations from here and there. Rather, when we should work more properly and more vigorously towards a, towards a approach that uses the basic sciences like chemistry and physics, those are the prime subjects which actually derives the essence of earth science or the panorama of this science. Now that's why I have thought that art is nothing but it can be treated as a scientific legacy of the universe by the creator to us. And actually, whoever had created this universe or the earth had been trying to focus on giving some information to us or whoever the living object or organism is. Now, you might tell me, you might ask me that how am I going to come in this conclusion? And why am I saying this? I am saying this because with increasing age or increasing time, I am watching everything from a ripple to generation of some magmatic pool to the evolution of the asteroids up to the evolution of some black hole or pulsar. Even before the genesis or the so-called Big Bang, afterwards through our generation, always and there had been some plans and which is now the most prominent scientific temperament in the physics as I have discovered through studies for the last 1 year and 1.5 years. The quantum physics and other mechanical processes or the literally solid state physics as well as hydrodynamics, the different aspects of molecular, macromolecular or micromolecular mm, facts, or rather I should say the focus of the building blocks of these processes throughout the universe had been some regular arranged fabric and which can be very complexly described in terms of some matrices. I think my audience or whoever is will be watching this had observed or had seen the movie called Matrix, and actually it's a simulation of reality. Now I cannot, I cannot stay in this subject more or less or more time because my focus right now is Earth, which has shown us or which has a legacy towards the universe, describing the sciences. Now, as we know, before I enter this, we know that minerals, which are the essential or basic components of geology, forms the rocks, which are aggregates of minerals, which are naturally occurring and lithified aggregates of minerals. So obviously, these entities which were formed by the different atoms and molecules through innumerable physical and chemical reactions had seen their changes from the beginning of time, or rather the beginning of the universe. Hypothetically, we have seen that it's generally, or it can be expressed as a space-time fabric, as shown by Einstein, who first thought that the gravity, that is the most, what should I say, that we feel gravity mostly. We can feel gravity whenever we are running or when we are jumping. So obviously we can feel gravity, but nonetheless it is the most weakest of all the four forces. That is like electromagnetic force and other forces with nuclear force, etc., etc. But the gravity is also dependent upon a constant, that is gravitational constant, as well as these different Planck constants in our universe is also dependent upon, are also constant, like velocity of light, gamma, etc., etc., etc. And as a result, the different constants had also been dependent upon these. And as we have seen from the experimental works by Einstein and other greats like Nikola Tesla or Schwarz in the recent days, that we actually live in a universe where the individual strings or the different matters can be described in terms of strings, and each and every single being, entity, atoms, molecules, whatsoever, they are, they are, or they can give a certain amount of frequency. That is called the kr square. That is the k where the string constant, and it entitles itself with some amount of vibrational energy. And in this universe, in this time, where space and time can create a tensor along which we are approaching, they are all constant. The equations may be time dependent and should be time dependent, because as we know that the time is the axis along which we all are running through. Now, the Big Bang, as the scientists say, that it was 14 billion years ago when something happened. When 13.5 to 14 billion years ago, in this scenario or in this situation, a very supersymmetric, infinitely dense small point of, or infinitesimal small point erupted out. But why, when, where? Physicists are still trying to answer that question. And that explosion is known as the Big Bang. And now, obviously, scientists have found out or have been analyzing, and they were very much successful in addressing or finding some gravity wave which helped us to unify the earlier mentioned forces like electromagnetic forces and as well as the graviton. And obviously from that I cannot go into the details, but string theory tells that there might have been that there were two brains actually operating. That is, one was string of another one universe, and the other strings those compose another universe, and those collided, and by the time of the collision, huge amount of energy was released, and that was the Big Bang. Now, it is very needless for me to say that those are practically or cannot be further discussed here, and I am not I'm not a suitable guy to talk about that because I'm not a guy from physics. It will be very helpful for you if you go find some GTR or General Theory of Relativity, or you can also find some beautiful tutorials from Stanford University where you can also find these. But this is a very important thing that we should consider, or we should find very interesting is that the gravity in this dimension may be weak because of the behavior or the axis along which we are approaching. And it might be that there are some loose dimensions where the gravity is much more stronger. And the discovery of the gravity wave actually tells that there might be the geodesics which are dependent upon the fundamentals of, or dependent upon the science that was created by Einstein and the other workers from the field of theoretical physics, tells that these space-time tensors are also dependent upon the advancement of time, as well as advancement of time is also, or can also, show us how a nuclear or an atom high radioactivity decays with time dependent Schrodinger, and that is also dependent upon the decay constant of this dimension or this universe. And it is quite fascinating for me to analyze the whole situation and make a statement about Big Bang. Apart from these facts, we should also know that Christopher symbols, which are important to understand the space-time fabric, it is also dependent upon the three dimensions and taking the time and some other dimensions. The tensor, or the number of tensors, or the number of dimensions, those will become much more higher and pretty much will be out of our domain. Within this theory, or the theorists, we have seen the advent of quantum mechanics as well as quantum science, as well as quantum biology. The quantum mechanics is nothing but it tries to analyze different types of uh, changes, like atomic changes. Even it also helps us to understand the evolution of biology. Nowadays, it is known as quantum biology, and it is also dependent upon some spins of the electrons, how the electrons and the um, release of energy of some atoms, of some excited atoms can happen, as well as what is this probability. It is also important. Quantum biology was coined by different scientists, and it is quite capable to analyze some of the minds of human, as well as it has also been very much capable to understand why place Bose effect in different types of Now, you might think that why am I telling you this about quantum biology? Now, it is because with the advent of or the generation of the earth, there was generation of life which had thrived from about 3.8 billion years. Now, the biggest question of us geologists was to understand how life came into existence. Now, definitely, we have seen life which is dependent upon water. Miscellaneous synthesis, which was an important part of generating of for the generation of life, which has shown us that the life had life had created or life was created in a complex process where probably some abiogenic molecules give rise to some biogenic particles like amino acids and etc. etc. The interesting aspect of their synthesis or the generation of the life was that the advent of atmospheric electricity or some, I mean, electrification or the cloud burst. It was important to generate by a certain amount of energy that could create some amino acids. However, those amino acids that Miller and Lewis synthesis gave us, it was not capable to give a good amount of or the perfect condition or perfect molecules that could be said that it was life. Actually it was protein. No, recently Hazen and his workers tried to do the same thing at high pressure experiments. At first they were not getting any result and come back. Then after a few attempts they tried to do that with the help of some rocks which were collected from Australia 3.8 billion years, 3.5 billion years old, and there were some clay minerals in them. Those clay minerals, they tried to do the same experiment in presence of those clay materials. And those clay materials, which have a very important property, is that clays are like forms alternate layers which are void in the in-between zone. And that in-between region or in-between region can or did produce some amino acids or protein chains inside that. When the same conditions of the pressure temperature and the electrification of the electricity was there. And obviously, these protein chains were important or could be said at the earliest life. So, these clay minerals of the rocks helped in flourishing life in presence of water. Now, what does it say? It is also saying that rocks created life. That's what Hazel said. That the rocks started creating life, and it is because of the rocks life came into existence in the earth. By the time of 3.8 billion years old, it was. As a result, we have seen that the 3.5 to 3.6 billion years ago, suddenly there was a rise of the oxygen in the atmosphere. And what the life is doing is that, in turn, is trying to change its atmosphere through what? Through the consciousness that scientists say, or that is also known as the work of Amarok. That is our conscious, which can only be described in terms of quantum mechanics, and that can be corroborated in any kind of living organism. And our brain microtubules, they act as a complex circuitry which interacts with the nature and creates some perception. Probably this was also true for the bacteria which were alive at about 3.8 billion years ago. However, they didn't have any neural network, but they connected, or they tried to connect with the nature itself, or the atmosphere itself, or the environment itself. And the environment, the perception they got that they had to release some oxygen in the atmosphere. And they were not, but they did it simultaneously all over this. Now, depending upon the reactions or the chemical reactions, whenever the electrons are lost or they are being by some atom, it is also a function of probability. However, those probabilities became juxtaposed at a certain time, and that generated a more oxygenated atmosphere, and which was more viable to flourish life itself. So obviously, there was a definite role of perception or conscious to generate as well as to flourish life in the earth. But before we enter into the 3.8 billion years ago, or before or after the discussion about after the Big Bang, now it is clear for us to understand that 14 billion years ago there was a Big Bang episode. 3.8 billion years ago there was a flourishment of life. However, the in-between region still remains in the dark. What happened in between this time? And how did we know about this? Now the grand theory of unification as well as the Big Bang, which we have seen, might be a resultant from the collision between the parallel universes or not. Now, the how or why why are the galaxies being separated from each other? It must be that apart from gravity, there are some other forces that is trying to do that. And how are you going to find that? It is called an event called red shift. Red shift of atoms or red shift of light from a galaxy to another galaxy, or for our galaxy or another galaxy. Red shift is nothing but the shifting of spectrum of light from lighter. Suppose these are two galaxies in these distances, and this galaxy is our galaxy, it is me, and this galaxy is their galaxy, which are both a part of the same universe. And then this is going away from this. Whenever the light was coming in from this galaxy to this galaxy at time t0, the wavelengths were like this. However, with increasing time, when this galaxy went this far, then same light waves, they increase the wavelength. Obviously, what will happen? A blue light will pretend to be or become a red light, and which is known as a red shift, which was discovered by Hubble and probably This was the reason he was also awarded the Nobel Prize. And this was a fundamental discovery in the fields of physics, because now you could see that there was a force and probably there was a big bang which has caused this massive expansion of the universe. And maybe there was some space-time ripple or the changes in the ripple that was also under consideration by this time. Now, obviously, the major issue is like what exactly happened after the Big Bang. Now, first 10 million years of the Big Bang, time evolution of fluctuations that is transformed to the end of the reionization epoch. This evolution pieced together from redshift slices similar to cosmic volume. Now, 10 million years ago, there was a faint light. Then there was a sudden dark, and from the dark, because of the reionization process, some lights came into existence, and then slowly, galaxies began to form. Now, Big Bang, whenever it occurred, it created huge amount of energy because of this brain collision or some form of energy dissipation from infinitesimal small point. And the first galaxies, whenever they formed, they had much more bigger suns because there were atoms like hydrogen, helium, and they were much more condensed in one area. And those galaxies as well as the universe was expanding. However, in between their spaces, there were areas but there was no light. And obviously the fusion process, whenever that started occurring, it created good amount of energy generation and the heating was being identified. However, before that it was the dark ages after the Big Bang. Now, evolution of the dark ages at redshift 200, that means 200 is redshift, it's a very distant galaxy from us. The more redshift will be, the galaxy will be far more distant. So the light has traveled that much of distance and it is that much early in nature. Now, we can also, or we were very much lucky to find out some of the photographs like this. This is a very popular false color composite of the whole universe that we have. And in these cold regions, blue cold regions, there are some points where there are warm red colorations. And this is a signature that there were some warm points during an episode of reheating of the galaxy through when some reionization of those Big Bang created hydrogen and helium atoms took place. Big Bang never gave generation up to all of these elements in the of the all of structures of the Earth. Big Bang was the startup point, a starting point for the galaxies. Now, from this simple diagram, we can clearly see that the first stars, which were in the scenario after the Big Bang, in comparison to the Sun, they are much more bigger. They had high amount of mass. Solar units like 1 million to 30 million. 4 to 14 solar radii, those are much more larger. And as well as the temperature changes during the evolution of the universe from the dark ages before the stars were formed. Well, like in this region, within the 10 million years or 17 million years. Now, Big Bang has declined, defined over time, the temperature of the spin temperature of the hydrogen that has not formed stars reflects the excitation state of the hydrogen, and the red line which shows a fall and rise of the energy and which can be referred as a reionization epoch of the cosmos where the dark ages were slowly being ended. And it is a simulation work where the blue and red dots indicate matter and dark matters during the formation of the first universe. The matters they collided or they formed at the center due to the gravitational force, and they collided, collapsed with each other, and they were forming small pulses of galaxies. Those galaxies started giving rise to these large solar masses or greater than solar masses. After that, those stars started giving faint radiations, which can be found as cosmic microwave background. Or before that, wherever the radiation was, which is known as the cosmic microwave background. And this was also an important finding in physics, where they found that it had a very profound amount of information about the genesis of this universe, and as well as those stars, huge stars, slowly started developing the late stages of the formation, and supernova explosions started to happen. Black holes started to exist. Now, supernova, what are the supernovas? Supernovas are nothing but they are the stellar forms or the or the initiation of a generation of a stellar cord. What happens in a huge stars like this? They don't have enough fuel at the core at the end stages of their life. At the end stages of their life, when they don't have enough fuel in their core, the ionic pressure or the radiation pressure is not that enough to carve out the effect of gravity. Gravity always works towards the center. We know that from the physics. And as a result, this radiation pressure fails to contradict the effects of gravity. These stars break down, releasing huge amounts of energy. And there might be some layers like onion shell through which these shock waves propagate. And these gives rise to huge supernova explosions. And these explosions are known as supernova. And these supernovas are quite capable to generate some heavy elements or isotopes by rapid capture of neutron or protons due to these huge explosive events, which were released from inside or outside or intermediate layers. And this is known as the rapid neutron capture process. So obviously, the hydrogen which were burned to helium, then carbon, nitrogen, oxygens were developed. After that, during the silica burning process, iron was created in some stars and then supernova explosions generated. Uh, Then these generated much heavier isotopes like iron and cobalt, etc. And then much higher like uranium, thorium, etc. etc. Dot, dot, dot. So this phenomena left some relics as well as some halos in this universe. Small parts, small galaxies, remnants of the galaxies. And we know that these processes took place only within 2 billion years or 3 billion years after the Big Bang. So obviously, there were some elements in the scenario well before the generation or the beginning of the solar system. Now, and this is a major idea that the cosmic abundance of the elements. The cosmic abundance of the elements, which also follows the Odo-Hawkins rule regarding even elements of even atomic number and elements of odd atomic number. And this is a general diagram of the hydrogen burning process and generation of the atom up to lithium and beryllium, etc., which are quite light elements as we consider them. Proton and neutron, they have been acting to form deuterium, and deuterium and then forming helium, helium acting with deuterium to form beryllium and then lithium inside the stars, and our sun is quite capable to generate these elements. The next cycle comes in the form of carbon, nitrogen, oxygen cycle, where carbon, nitrogen, oxygen, and those elements are big. Okay. And the next sequence or the next things that we know and we did is that silica burning process, where silica burning with other elements like nitrogen and neon creates iron. And as the isotopes or the generators of the iron or cobalt, which are from the isotopes, which are very low half-life, the core of these stars, like in the mass of our sun or more to that, they are very much enriched in iron, cobalt, etc. However, apart from the supernova explosion, that is the generation of the shock waves and the much capable processes like slow neutron capture process, rapid neutron capture process, where already existing isotope captures some protons and neutrons in the structure, releases some energy and gets rise to another heavier isotope within a quick instant of time because of the shock wave is acting in a high energy situation. And that can only be demonstrated through the supernova or some huge explosion. And this is more or less a remnant of the supernova explosion, which was type 2, which was found. Now obviously these elements, heavier elements, lighter elements, they are all being generated in the earth. They are all resultant of a process, and slowly we are observing that simple things are getting rather complicated. And then becomes the advent of solar system. Now, before the advent of the solar system, we should know that scientists are nowadays saying that it was a resultant of the supernova that met up with some amount of huge solar storm or something like that, that created the initial instability in the solar system to generate the protosun or the protosolar nebula. In that nebula, because of these higher energy situations, different workers have found out that those elements reacted with each one to form different compounds like perovskite, chlorsulfur, nepheline, corundum, etc., 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 etc. and which are found in nowadays meteorites, some of the meteorites and some of the meteorites. The types of the meteorites which appear these earliest legacies of our proto-sun or the solar nebula. And that's how it probably looked like before the advent or just when the proto-earth was beginning to form. Violent explosions and those chunks of the compounds getting entangled to each other and then when colliding, they are creating heat energy, melting, etc. etc. And suddenly there was some amount of water poured into the system. Now, there are evidences of 4.4 billion years ago there was some water present in this earth. 3.8 billion years ago, we also already know that life was starting to thrive or trying to thrive in this hostile atmosphere by generating oxygen. Now, different workers have told as classical worlds for evolution to take place. However, in more natural scenarios, the rate of evolution depends on the degree of entanglement present in quantum organisms. With respect to classical organisms, if the entanglement is maximal, if they try to communicate and they try to be in a unison with each other to make a system better, then it turns out favorable that they will evolve together. And the age of consciousness as well as quantum biology just started by that time, what I have already mentioned before. Now, obviously, from the system, that is from the beginning, that is, we were talking about the formation of the, Big Bang and then space-time fabric, and those fabrics got collided by the time of the Big Bang. Then there was a epoch change. There was cosmic dark age, and then microwave background, and then supernova, and then suddenly comes life. So obviously, this is a huge process taking place or going or moving slowly towards more complex system. Now I don't know whether in this 13 to 4.5 billion years ago there are other types of life forms. But if there was, I wouldn't be that much surprised if there was a minimal amount of water and minimal amount of entanglement was present in the atmosphere. But to understand these systems, we will also need to know some physical entities or the physical phenomena like melting that I already told during the generation of these meteorites or the generation of the solar system. That is how the thermodynamics acts and thermodynamics rules this universe in their science, as well as there are also rules of solid state physics. There is also role of physics that I have already told. Thermodynamics, it is one of the most ancient science in the physics, and I am not going to get much of the detail of that. However, changes in the universe is governed by phenomenological factors. Phenomenological factors. Now, why I am telling this that now phenomenological factors like temperature, the factor like pressure, factor like chemical potential, factors like these are intricate details which actually controls the free energy as well as free energy of different systems, as well as their mobility, as well as their rate of diffusion, as well as the electron spins, and these practically control all of the processes those are acting or those are those are created and being practiced in the earth by forces of nature. Now, basic types, basic things of the quantum thermodynamics is that there is a if you do some work, suppose I am going to push this and it will be requiring energy. There is some internal energy present in the system. There might be some heat energy in this. And the earlier stage where the energy was E2 and the later stage if the energy was E1, then obviously E2 minus E1, that is heat released or heat induced in the system, will be Q, that is the total energy was present in the system, into T into V2 minus of V1. If that is, if I can change the volume of the substance from V2 to V1. Now, in any type of cyclic process, we know that heat can or cannot be, uh, I mean, taken, which you have given, you should take, and it might come into the same way. If it comes back to you in the same way, then there should not be the problem in between the work done and the energy cost. But in most of the cases, that doesn't happen. And as well as what is a function of pressure and volume, as we can already see in this example or in this expression. Now, this state property is known as enthalpy, which is dependent upon the energy as well as they are also dependent on the pressure and the volume. And when used with the work done in the system in terms of pressure and volume, that is the state property, as well as the degree of randomness in a system is defined as entropy, which I am going to discuss next. But this will be more or less for today. So goodbye.